two types of hypervisors. We have type 1 and type 2. And there is a difference between them. The first type, its function is very similar to a normal operating system. So normally the operating system is installed on top of the hardware, and its job is to manage the resources and provide abstractions to user processes to access its resources. Type 1 hypervisor does pretty much the same thing. It's installed on top of the hardware, and it is allowed to directly manipulate the hardware. On the top of the hypervisor are the actual operating systems. If they need to use the hardware, they have to trap into the hypervisor. Trap is like a system call to the operating system. Remember, if we have to do I/O, or we have to an I/O operation, then we make a system call, whether that's opening a file, or printing, or accessing the disk, or whatever we need to do. We make a system call normally and let the operating system do that, because these are special instructions that only are allowed to run in the kernel mode. So we have this exactly same situation here. Type 1 hypervisor is like an operating system, and the guest operating system's virtual machines are installed on top of it, and if they can run normally, whatever instructions they need to run, but when they need something from the hardware, they trap into this hypervisor, and the hypervisor will emulate that instruction for them and access the hardware and do whatever is necessary. So that's the first type. And then, so we have type 1. So type 1 hypervisor is like an operating system. It is the only program that runs in the most privileged mode. And its job is to support multiple copies of the hardware called virtual machines. And in this case, these virtual machines are no different than regular processes running in user mode. Now we have type 2 hypervisor. have, it is not installed on the bare hardware like the first one, but it relies on a host operating system which is installed on the hardware to provide the functionalities that are necessary to access the hardware. And it runs on top of that, much like a user mode process, like the rest of the processes that will run, or applications that will run on top of the operating system. So what we have is the hardware, the operating system, a bunch of applications, and one of them happens to be the hypervisor. So it is a program that relies on a host operating system to allocate and schedule resources. But it still pretends to be a full computer with CPU and the various devices that come with it. The operating system which runs on the top of the hypervisor, both in type 1 and type 2, is called a guest operating system. Both types must execute the instructions on the machine in a safe manner, which means a guest operating system is allowed to access its own page tables and even mess with them, but it should not be allowed to mess up the page tables of the host operating system or of any other guest operating systems that are running. So the hypervisor is responsible for that. So both must execute instructions sent in safe manner. This is a table with example of type 1 and type 2 hypervisors. So type 1, we have ESX server. We also have these I believe that's Microsoft's Hyper-V, and this Xen of type 1 hypervisor. Type 2 is the popular VMware. The first version was called VMware Workstation. Now we also have VMware Fusion and others. Now there is a category here called Power Virtualization. So I'm going to explain what that is. That's called part virtualization because with virtualization we said that the guest operating system should not realize that it's running in user mode. When we have pair virtualization, we don't follow this rule. It means that the guest operating system explicitly knows that it's in user mode. It does not pretend to be in kernel mode. It realizes that it's in user mode. And when it needs to execute kernel type instructions, it calls a special interface where they are defined. They are called hypercalls. So these hypercalls is a set of instructions which allows the guest operating system to send requests to the hypervisor. So in pair virtualization, it does not try to present the virtual machine that looks like an actual operating system with physical hardware. That's not what it's trying to do. So it never aims to present the virtual machine that looks like an actual hardware. But it presents an interface. It's a machine-like interface which shows that it's a virtual environment. Why would we want to do that?